Hi, I'm Leah, and this semester in Risk and Reliability, I'm going over the system of a biosafety level 4 laboratory. These are the kind of laboratories that exist at places like the CDC and military labs in countries around the world, and they study microbes like this little guy, Ebola. Ebola, smallpox, yellow fever, anything that's really virulent and really likely to kill a lot of people. So the safety restrictions in these labs are extremely tense, and for very good reasons, because the risk of anything in these laboratories getting out is absolutely too horrible to comprehend. So when you're looking at a big laboratory and a big scientific area in general, there are rules that are called the biosafety level 1 rules. And these are things like admittance to the lab is controlled, the lab has hours, the lab has locking doors, surfaces must be washed after an experiment is performed, equipment must be washed, things are disposed of in a sanitary way, hand washing, lab coats, that kind of thing. And then, from that stage, we build upon it and go to the biosafety labs level 2. And this is where a lot of work is done with stuff that comes out of the hot labs, which are the biosafety level 3 and 4 that we'll talk about in a minute. But this is where work on sanitized samples from those labs is done. It's a lot like an operating room, typically. There's microscopes. It's a place where the admittance is restricted even further than biosafety level 1. There's frequently a keypad, sometimes even a fingerprint to get into this point. The hours are restricted. Frequently only one person or one group of people can be working in there at a time to create a single directional flow in and out of the biosafety level 3 and 4 labs where the really dangerous stuff is happening. So, in the biosafety level 2 labs, must wear scrubs. The locker rooms going into the higher labs are considered biosafety level 2. Disposable scrubs, laundry area, sanitary shower, that kind of thing. Then we're moving forward to the biosafety level 3 labs, and these are kind of a different animal because you work with dangerous microbes there, but almost everything worked with in a biosafety level 3 has a vaccine. So in order to be authenticated and able to work in a biosafety level 3 lab, you have to get all of these vaccinations, and that poses a problem for some technicians. That's one of the big risks of this line of work. Some people just cannot tolerate all of those vaccines. I mean, somebody's probably gotten sick from a flu shot, achy back, that kind of thing. It's a lot different when that shot is for some hemorrhagic fever or something. That can definitely be worse side effects. So, if there's an incident in biosafety level 3, you vaccinate, you're going to be okay. But we're moving forward into the biosafety level 4 where it's a very different story. Everything that's worked with in level 4 transmits between people very easily. It transmits through the air a lot of the time, and it can infect very quickly. So the barriers around the biosafety level 4 are really important. And that's really the part of this system that I want to do my risk analysis on this semester. Basically, to go through what a person working in a biosafety level 4 lab goes through. They go into a locker room that's level 2. They change into disposable scrubs. None of their possessions go any further than that because they'd have to come back out through the sterilizing process, which I'll talk about in a minute. So they shower, they put on scrubs, they tape the sleeves of their scrubs to the edge of their gloves actually to create a seal there. They go through into the next room, and here's where the spacesuits are kept. And the spacesuits are the most important line of defense between the workers and the mysteriously hot air inside of the biosafety level 4. Anything could be in that air. Everything is probably in that air, and that's the assumption that workers must operate under. So, you have these spacesuits. You've probably seen them in movies like Contagion. They're big, they're rubber, they inflate from a dry air source that's filtered with a HEPA filter on the outside of the building. And the suits are constantly under positive pressure. So if something happens, if there is a rip in a suit, which can happen because they aren't perfect, then the air is going to flow out of the suit and into the room and keep the microbes out from the area in which the person is. Because essentially what the suit does is it creates a bubble of safe air around the worker. The air inside of the suit is the same as the air outside of the biosafety level 4. That tube going from the outside to the suit is basically a very well secured breach in this security system in order to keep the workers alive and let them work in these conditions. Every worker maintains their own suit, and this does bring about another level of risk because you're tired, you've been working a long time, you've been hunching over. A lot of medical work is done in biosafety level 4 labs, frequently animal studies. So there are scalpels, there are monkeys, which crazy sharp teeth. I mean, I've heard a rumor that a 6-pound monkey and a 200-pound man are pretty evenly matched in a fight. So any of those animals rips in the suit or handling sharp objects, especially the hands of the suit, can be an issue, and that's why they wear another layer of gloves underneath it. But after the worker gets on their suit, they go through, and then they go through a sanitation shower, which is basically hot bleach. And it runs, they have no control over how long it runs. It runs for something like 3 minutes is one of the standards that I read, but I've heard some other numbers thrown around. It might be something country specific, and I'm still looking into that. But they stand under this shower of hot bleach until it turns off, and then the outside of their suit is sanitized. They go through, they put on leather boots, I mean not leather, rubber boots that are kept within the lab. They do not leave the lab. And that protects the soft rubber feet in case there's anything sharp on the floor, so that there's not any sort of tears in the suit in that direction. Then they connect to a hose in the ceiling that blows cool, dry air from the outside world into their suit, and they go about whatever work they have in level 4. Now, if they want to pass some sort of information from level 4 to the outside, what might be necessary with results or data or something urgent, there's a phone and a phone on the other end, but it's really hard to hear these people talk because within the suit there's a rush of air constantly. So basically what they figured out is silpats, like you use in baking, that was actually that's something that became very useful in level 4, because you can write on a silpat with a Sharpie essentially, and then it goes through a tunnel where it's fumigated and also given a shower of flaming bleach. I mean, not flaming bleach, boiling bleach. It goes through to the outside world, and it is a sterilized piece of evidence, and the silpat survives like paper never would. So that's another egress that can cause some sort of security issue. If something in that channel's wrong, if those sterilization things aren't working correctly, that's definitely a risk, because that's going straight from the hot zone to the hallway outside, where there's not the same kind of restrictions on who can get in there. And then there's also the air in the hot zone, which will always be an issue, because a lot of these viruses can spread through air transmission. So there's very complicated filtering systems, big HEPA filters. These labs are all under their own HVAC control. They don't share it with the rest of the building. And then, most importantly, the labs are constantly kept under negative pressure. So if there's any sort of breach in the system around it, then the air is going to flow into the lab instead of out of it, and hope that the breach gets corrected soon. There's also a refrigeration system inside of the lab where a lot of these samples are kept, because they aren't going to keep a sample of Ebola or smallpox in a different, less secure location when they already have all of these intense restrictions in place in the level 4 lab, and safe to keep them there. So there's a big cryogenic room. The viruses are kept in little vials, and they're above a bed of liquid nitrogen, these big freezers. And that's also an important thing to worry about. Those freezers have to be kept at a constant temperature 24/7 all the time. Too cold, you destroy the virus. Too hot, you destroy the virus, or it becomes viral and can spread into the air. So the refrigeration room and the HVAC are both dedicated to this facility and very important. This is a pretty simple overrun of the system. It's one of those things that has been designed by many government agencies, and it is completely over the top in every way for the best reasons. It has a dedicated hospital. The walls are made of varying degrees of bulletproof steel, and even with all of these things in place, it's still a pretty scary thing to think about. Just one tile room, one incident away from unleashing the things that could kill many, many people. So, this is the system that I hope to analyze this semester. I want to analyze the risks and prove that they are as minimal as I hope they are. Thank you.